works. Today, we're diving deep into the hidden world of warehouses to learn a secret language. It's a language that allows these massive buildings to manage millions of items with mind-blowing precision. Let's get into it.
Seriously, just think about that for a second. 1 million different items. It's like finding a single specific needle in a haystack the size of a football field. And yet they solve this problem thousands of times an hour, almost perfectly every time. How on earth is that even possible?
Well, the answer isn't some crazy complex robot or an army of geniuses. It's actually a concept that's brilliantly simple, but incredibly powerful. It all comes down to the humble storage bin. This is the single, fundamental building block that the entire universe of a modern warehouse is built on.
So, here's how we're going to break it down. We'll start with how a bin acts as a digital address. Then we'll look at its anatomy and see how you can create millions of them instantly. After that, we'll explore the warehouse's digital twin, see how these bins are put into action, and finally, uncover the real secret to optimizing the whole workflow. Okay, first things first, we have to understand what a bin really is in this world. And trust me, it's not just a plastic box. In the language of the warehouse, it's a super precise digital address. Right, here's the key idea. A storage bin isn't necessarily a physical container. It is the smallest piece of space the system can identify. It is the one exact digital coordinate for absolutely everything, whether it's a giant pallet or one tiny little screw. You know, the easiest way to get your head around this is to think of it like a mailing address. Your house has a unique address on a specific street in a specific city, right? Well, it's the exact same idea. Every single spot where an item could possibly be stored gets its own unique address. That way, nothing can ever truly get lost. And what makes this so powerful is that the address isn't just random letters and numbers. It's a coordinate system. A code like 010203 is basically a map. It tells a worker or a robot exactly where to go. Aisle 1, go to the second stack, and look on the third level. It's simple, it's logical, and it's foolproof. But, you know, just knowing the address is only the beginning. To be really useful, the warehouse system needs to know a whole lot more about that spot. So let's take a look at the anatomy of a bin. So, just like your house is on a street and that street is in a neighborhood, a bin belongs to a storage section. Think of that as a specific row. And that section is part of a larger storage type, like maybe cold storage for frozen goods or bulk item storage. This hierarchy keeps the entire warehouse perfectly organized. And this is where the real intelligence kicks in. Every single bin has its own digital profile. The system knows its size, it knows if you need a special kind of forklift to get to it, it knows the maximum weight it can hold, it even knows its exact geo-coordinates to calculate the most efficient travel paths. It's an incredibly rich set of data for every single spot in the building. Okay, so we've got these super detailed digital addresses, but a modern warehouse can have hundreds of thousands, even millions of them. I mean, how on earth do you create and manage all that information without it becoming a total nightmare? I mean, can you imagine the horror of trying to type in 1 million of these addresses by hand? It would take forever, and you'd make a ton of mistakes. So, of course, the solution is automation. Instead of creating one bin at a time, you build a smart template. And the process is just brilliant. You just define the structure you want, say aisle, then stack, then level. Then you create a template. For example, NN could mean a 2-digit number. NC could mean a letter. A template like NN-C-NN can then instantly spit out thousands of unique addresses, like 01-A-05, 01-A-06, and on, basically mapping out an entire section of the warehouse in seconds. So all this data, the coordinates, the attributes, the hierarchies, it's super powerful. But at the end of the day, it's just numbers and letters in a database. To make it truly useful for a human operator, you need to be able to see it. You need what's called a digital twin of their warehouse. And that's where the graphical warehouse layout, or GWL, comes in. It's pretty much what it sounds like, a visual, two-dimensional map of the entire operation. It turns all that abstract bin data into a tangible, interactive floor plan that you can actually look at. And get this, it's not just a static blueprint. A warehouse manager can use the GWL to see, in real time, which bins are empty and which are full. They can check stock levels in an entire aisle with a single click. They can even see the last known location of a forklift. It's basically a live command center for the entire building.
All right, so far we've built this perfect static model of the warehouse. But a warehouse is all about movement, right? So how does this whole system of bins actually guide the real-world work of putting things away and picking orders?
The key concept to understand here is the activity area. What this means is the system stops thinking about just the physical location of a bin and starts thinking about the job that needs to be done. For example, it can logically group all the most popular, fast-moving items into one picking area, even if they're physically spread out across different aisles.
And these activities are pretty much the basic verbs of any warehouse. You've got put away, which is storing new stuff. Stock removal, or what we call picking, which is grabbing items for an order. You've got physical inventory, which is just counting. Each one of these jobs can have its very own logical map, its own activity area, laid right on top of the physical warehouse layout. And this brings us to the final, and honestly, the most important piece of the puzzle. Why go through all this trouble creating these logical activity areas? I mean, why not just send workers to the physical bin locations? Well, this is where the real magic happens. This right here is the game changer. When the system generates a task list for a worker, say to go pick 10 different items for an order, it doesn't just give them a random list of locations. It sorts those locations into a very precise, calculated sequence that's designed for one thing: maximum efficiency.
Now, you might be thinking, but wait a second, why would you sort the same bins differently? A worker might have to visit the exact same 10 bins for a picking task one day, and then for an inventory count the next day. Why would the system give them a different path each time? Because the goal is always the most efficient path for the job. For picking an order, the system might create a perfect, snake-like path up and down the aisles to minimize walking distance. But for counting inventory, maybe it's faster to sort them purely by number. By sorting the bins differently for each activity, the system makes sure that every worker is taking the absolute shortest, fastest, most logical route possible. It shaves seconds off every single task, and those seconds add up to millions of dollars in savings.
So from a simple coordinate system to a dynamic, self-optimizing workflow, that humble storage bin is really the unsung hero of modern logistics. The next time a package arrives at your door with what feels like impossible speed, maybe you'll think about the elegant, invisible digital journey it took, all thanks to the secret language of the warehouse. Have you ever stopped to think about how